In this video, you'll learn about the problems of using synchronous communication between microservices and how to avoid them by switching to the asynchronous communication style and the use of a message broker. Imagine a scenario where after receiving a request from a client, our microservice needs to reach out to two other microservices. Also, each of these services need to get in touch with other services, which in turn might need to further reach to more services. There may also be services that depend on the services that our service depends on. We originally fine-tuned our service so that it never takes more than 300 milliseconds to respond to our client requests. However, when we started making synchronous calls to one of our dependent microservices, we had to add to our time the 200 milliseconds that service can take to respond. That was still okay in the beginning, but unfortunately, when that dependency eventually started calling another dependency, and that one yet to another one, our overall average latency bumped to 1450 milliseconds, which is bad. On top of that, if one of our deeper indirect dependencies starts failing, even if temporarily, it can cause all of the services that depend on it to also start failing. And the effect keeps cascading until potentially most of our system becomes unavailable. One important concept that you should keep in mind as you embrace microservices is the Service Level Agreement, or SLA. The SLA is basically a commitment between you as a service provider and the client. For instance, as part of our SLA, we could have defined that our service can be expected to be up and running 99.9% of the time. So, when our clients choose to use our service, they should expect it to be down approximately 44 minutes during the month, which the owners of the client will have to decide if it's acceptable. However, when using synchronous communication, calculating such numbers for our service SLA gets more complicated. Our deepest dependency is also advertising a 99.9% uptime in their SLA. And let's say that all of the services initially advertise that same value. However, in our scenario, when dependency 4 fails, it impacts the SLA of dependency 3, which now sets its SLA down to 99.8%. This in turn impacts the SLA of dependency 1, and ultimately impacts our own SLA. Now, with an SLA of 99.6% uptime, our clients would be subject to about 175 minutes of downtime across the month, which is way below of what we wanted to provide initially. So the synchronous communication style suffers from an increase of latency due to the chain of calls. It can significantly amplify the impact of partial failures and can potentially reduce the SLA of our service. Now, let's look at the asynchronous communication style. Here, the client does not have to wait for a response in a timely manner. And in fact, depending on how the communication has been set up, there might not be any response at all. To enable such communication, there is usually an intermediary called the message broker, which is pretty dumb in nature, meaning that it has no business logic on it, and it is also highly available. With the message broker in place, the service client sends messages to the broker and the broker forwards the messages to receivers as soon as possible. The messages can be received by two types of receivers. A single receiver, in which case we think of the message as a command via which the client requests an action on the receiving service. We could also have multiple receivers, where there are multiple services that subscribe to the events published by the client service. One of the key benefits of using asynchronous communication is that it enforces a microservice's autonomy. Let's see how it's enabled. In a single receiver scenario, we would have again our client talking to our service, but our service will not talk to its dependent service. It will instead send an asynchronous message to a broker, and it will immediately acknowledge to the client the successful reception of the request. The dependent service will consume this message from the message broker as soon as possible and will eventually provide a reply via the same broker. At that point, the client can request a status of its initial request to our service, or our service can notify the client of the response. All of the services in our system would follow the same message-based approach, including cases where a reply is not required from the called service. The great thing about this kind of layout is that when one of the dependent services fail, it would not cause any impact on the other services, since all of them have been decoupled from each other and only talk to the message broker. So the same SLA that one of the services presents can be honored across the entire system, assuming that the message broker offers high availability. So, with asynchronous communication, partial failures are no longer propagated. Each service has its own independent SLA, and best of all, the autonomy of all microservices is enforced given the lack of coupling between them. One of the nice things that asynchronous communication provides is the ability to asynchronously propagate data across services. In the synchronous communication scenario, when the client requests the user's inventory, and since the inventory service only has the data that's relevant to it, inventory has to first talk to the catalog service in order to retrieve additional details about each item. How can asynchronous communication help here? Well, thanks to the presence of the message broker, what we can do now is have the catalog service publish an event each time a catalog item is created, or updated, or deleted. Such event doesn't have to have all the details of each item, but only the ones of interest to client services. We can then have our inventory service listen to these events and create its own collection of catalog items in its own database. As long as we have a highly available message broker, the list of catalog items in the inventory database should be eventually consistent with regards to what's in the catalog service. Now, when the client requests the user's inventory has no need to go out into any dependent service to request item details. It has everything it needs in its own database, and it can immediately provide a reply to the client with no additional latency. So, thanks to asynchronous communication, we can enable eventual consistency across our system, the autonomy of our services is preserved, and the previous inter-service latency is reduced or completely removed. This video is part of my full course where I explain in detail how to implement asynchronous communication in .NET Microservices. If you'd like to know more, please check out the links below this video. Thanks for watching and see you next time.